Welcome to this section where we are going to discuss the second interview question, which is find the kth smallest element in an array. So what does this question actually means? Suppose we have given an array which is containing these following elements, and we need to find the kth smallest element. So k can be 3, 4, any integral values. What we say that what is the third smallest value in this particular array? This question simply implies that. Now we need to determine our algorithm. So there are various methods to solve it. The first method, which is the easiest method, is to sort the entire array first. So if we sort this particular array, then we are getting the final output here as 3, 4, 7, 10, 15 and 20. And out of which we will see that what is the value in the third index. So it is 7. So we can see that 7 is the third smallest element. So this is one of the method. But we are not going to discuss this method for now because this is one of the easiest method, and we are not going to get understanding of the another method which is a more reliable and also a very good efficient algorithm, which is not taking much space and time execution, and also it will help us to reduce our execution time. In the later phase of this course, we'll understand in more details the analysis of algorithm, in which we are going to discuss on space and time complexity, which directly determines the execution time required for that algorithm to complete its execution. So in this particular method, it is going to take a particular time complexity for now is larger than the method 2. So let's understand the method 2 for now. So in method 2, we are going to understand a famous algorithm which is called as quick select. So it came from the same analogy as we do for quick sort. Here the algorithm will look little bit similar what we do in our quick sort algorithm. So let's understand the algorithm first in more detail. So take the same example here, 7, 10, 4, 3, 20 and 15. Now here also we will as taking the value 15 as the pivot key or the pivot element. If you recollect, then in the quick sort also we take the pivot element as the last element. So you can take any element as pivot. For now we as assume the last element to be taken as the pivot element. So once we taken this as pivot element, now as we particularly find who are the elements who belongs to left side of this particular element and who belongs to right side of this element, and accordingly we do the swapping, and finally we get a situation in which 15 gets its right position, and the left hand side and the right hand side will get all the elements which is actually present when the particular list is sorted. So we now have to find out the correct position of 15. So we'll do the same step. We need to find out all the elements from the start to this particular index and figure out who are the elements belongs to right side and who belongs to the left side. So if you start with 7, 7 it belongs to the left side because 7 is smaller than 15. So that's why we are not going to change this position. 10 also follows the same. 4 also follows the same. 3 also follows the same. 20 is the highest element which is going to be right side. So we are going to swap that element to the right hand side. So in the next step, we are going to get this particular intermediary step in which we are already get our 15 position as the correct position for the 15, and in the left hand side we are getting all the unsorted element which is lesser than 15, and we in the right hand side we are getting all the unsorted element which is higher than 15. Now we need to figure out the what is the index value currently holding in 15. What is the index value? So if we see the index value is here is 1 2 3 4 5. So fifth index value it is. But in our question we have taken the k smallest element to be determined as 3. So here k value is 3. Now I need to figure out who is the third smallest element. But here if you see, I am getting the fifth smallest element here. If you start from here, this is the fifth smallest element. This is the first smallest element, second smallest element, third smallest element, fourth, and this is the fifth one. But I need to figure out the third one, not the fifth one. So I will narrow my search to this section now, because I will not care anything for this section, because at the end of the day my approach is to figure out the third one, not anything else. So in this section it is very much sure that I'm not getting any element which is the third smallest, because if this is the fifth smallest, then the numbers after this particular 15 value are going to be higher than 15, which simply means it is greater than or maybe the sixth smallest element. So it's never going to be third. So that's why we will never going to search in this section. Then we will remain with this section only. Now we'll apply the same algorithm again, in which we'll take assumption that 3 as a pivot element and figure out who are the elements belongs to the left hand side and who are belongs to the right hand side. So once we figure out, then we'll see that 3 comes here, followed by 7, 10, 4. And here in the left hand side we don't have any element. In the right hand side we have some set of elements which is unsorted for now. And now we need to figure out who are the current element, who is the third smallest element. So if you see, this is the first smallest element, as after this particular operation I'm going to get my correct value of 3, but I don't want 3, I want the value as third smallest element. So again I have to search, but in this time we don't have to go to the left hand side, because this is the first. Third is definitely going to be found in the right hand side, because this is the element which is higher than this particular value. So we'll again do the same iteration for the partition values, in which we are going to figure out what is the next pivot element and then find its correct location. So then we determine that now the next value is 4 and followed by 7 and 10. Now if you see this, this is the second smallest element, not the third. Again I will have to search in this particular set. So here if we do the again searching, then we'll see that 7 and 10 are already in particular sorted manner. And now we can get that this particular element is already in its correct location, which is the third smallest element. Now we figure out 7 is the third smallest element. And this is how we use one of the portion of quicksort to figure out the kth smallest element. So here the k value I have taken as 3. Similarly, if you take any value of k, suppose 4, 5, 6 or anything, accordingly you will follow the same iteration and you finally get the same output as we initially set for. Now let's understand the same thing using the Python programming. So to implement this following algorithm, we can start first with the initialization of this particular array or the list. So I have taken the following elements and initialize the k value to 3. So here I am determined to figure out the third smallest element in this particular list. And I'm calling a function with 4 parameters, which is passing the value of a, k, starting index of a and the ending index of a. And finally, this function is returning me the kth index value. So finally I'm printing that value here. So let's implement the logic behind the kth smallest function. So first thing we'll implement is the figure out the pivot index. So I will write pivot index equals to, I will call the partition function here, partition, and I will pass 3 values here, a, start, comma, end. So once we figure out the pivot index here, then I have 3 situations here. So first situation is, if suppose the partition index which I got after the partition algorithm is same as the location of the kth value, then simply I will pass the value or the return the value of pi, and that is our final answer. But this is the straightforward situation. But there will be another situation in which the pi which I received is higher than the kth value. So in this situation, I will no longer search in this area, because this area is never going to give us the value which is existing in the k smallest value. So we are going only in this direction only. So we reject this area and we'll again do recursion call in this particular segment now. But the third situation will also be same. Here in this situation, the pi I received is smaller than the final kth value. So kth smallest value exists in the right hand side, not in the left hand side. So I will not search in this direction, I will search in this direction only. So we have total 3 situations, and same we will implement in our if else conditions as well. So the first situation will be, if pivot of index minus start is equals to k minus 1. So I am taking the value of the difference value from the pivot index to start and comparing with the kth value, and if this value is still same, this simply means that I don't have to do any further operation. I can simply return the value of a of pivot index, because that is that value which I am expecting. But if that is not the situation, then there is another if else condition I will put. If the value which I received is higher than the current k value, which is our second situation, then in that situation I will do return, but here I will do the recursive call because still my kth value is not determined yet, but I know where I can find, which is in the left hand direction. So I am calling it again in the smaller array. So I am starting with the value as a, then passing the value of k value as simply k here, then start location as start, but here the end will be not the initial end, it will be pivot index minus 1. So this is what actually we are expecting to figure out or get the value from the left hand side direction. But if the situation is the third case, then in that situation we will perform the return of same recursive call along with, now the k value will be the updated value. So if you see that if this is the kth value and this is my pi value, and now I am decided in the third case I am not going further in this situation because k is belonging here, and I will not going to search any longer in the left hand direction of the pi, which is the pivot index. So my updated start will be here, it will be not no longer will be initial start. So I have to update my start as well as the kth value, because kth value is the kth index from the start location, this is the reference. But if we take this as a reference, then the kth index will be not same, it will be different as per the reference from this location. So I will mention that reference value here, which will be k minus pivot index plus start minus 1. So this is the reference basically which I will get in this particular k value here. Then what I will do, I will call the start value. Now the start value will be always be going to be the pivot index plus 1. So pivot index plus 1, and the end value will be always be end node itself. So we are not going to change anything. So the code looks like this. And finally we are done with the implementation of our this function, which is the kth smallest. Now we'll call our partition function. So partition function definition, we have to define it here. So we'll mention the same name which we have mentioned in the kth smallest function. The parameter will be a followed by start and the end value. Now I will choose the pivot element. The pivot element here I choose as the last value or the last element of the array. Then once we figure out the pivot value, then the next step is here to initialize I to a start value or the start index value here. Then we will run a for loop with j as its variable in range from start to end. And in this whole iteration, we will compare one thing, which is if a of j is currently smaller than equals to pivot, then we are going to perform our swapping operations here, a, and increment the value of I here. So this is the simple operation which we are doing, that figuring out the pivot elements particular indexes. By using this comparison, we are finally achieving the final index which we are going to do the final swapping, which is the location which we have located after this for loop. So we will do the same thing here. We'll do a of particular location with the current end value, which is the pivot value. So this finally ensures us that finally pivot element is in its correct location. And what is the element of the pivot element currently we are holding, which is the ith value, because this is the value which currently holding the right location of the partition index. So this value we are returning. So this index value is returned to this variable when we call, and all the comparison happens accordingly. So this is how we can implement our functions here. So let's run the following program which we have implemented with the given inputs. So here you can see that the output I am getting is 7. So this same thing we also received while doing the dry run. So this is how we can get our output using this particular algorithm. And same approach we can also follow for finding the kth largest also using the same approach. We can provide different values of k here and figure out the output accordingly. Thank you.